How often did you find yourself in the annoying situation of steering the wheel towards a completely different direction for delivering a new feature due to lack of clarity of what to express inside your code? Fear not, because this video is going to provide you the answers to all those questions. I want to share with you stories from the trenches, techniques and mechanisms for finally cracking the code and getting enough documentation to succeed in your software project. Are you ready? Let's dive in. Hi everyone, my name is Luca. I'm an architect, super passionate about software architecture and the intricacies of its social technical aspect. I spent over 20 years of my career working from embedded or low-end devices to global distributed system in the cloud, and now I'm principal serverless specialist in AWS. Where are we? Oh yes, documentation. Documentation plays a critical role in the software development process, especially in distributed systems such as microservices, micro frontends, data mesh. Documenting software architectures helps to align teams, scale businesses, and empower developers. Many people think architecture is just a technical topic. It's definitely not just a technical topic. Keep in mind that a lean mindset is essential here. We need to have enough design upfront to start our development process, and we should maintain our diagrams to democratize the evolution of a system across every function of your tech department. Too often, I have experienced teams not fully understanding what they have to build, rushing to create the proof of concept that nail down the complexity of a technical part, only halfway through the process realizing that they forgot a key detail that now requires a greater effort than designing the project with that in mind up front. It's time to change our habits and dedicate enough time in designing upfront enough architecture that will allow us to move forward our projects. I don't want to overwhelm you with thousands of techniques, but just the ones I have seen more successfully applied in many organizations that have brought benefits in the development of software across multiple teams. During this video, I'm going to introduce you to several techniques: architectural decision records, request for comments, event storming, and the C4 model. At the end of this video, you will have a solid understanding of each method and be well equipped to start changing the way you model and deliver software. Why documentation matters? Software modeling at the beginning of the project is a fundamental step that too often is ignored or teams don't dedicate enough time to this practice. This will accelerate drastically the development process because everyone has clarity of intentions. That doesn't mean we have to nail down every single detail up front, but have just enough architecture to start the process. The focus before coding should be nailing down the architecture characteristics and business characteristics. This shared understanding provides several benefits: streamlining decision making, simplifying onboarding for a new team, facilitating collaboration between cross-functional teams, reducing potential misunderstanding, ensuring consistent knowledge transfer. Now, there is no denying the value of well-curated, structured, and updated software documentation. It's a must-have nowadays, and we cannot forgotten. When everyone inside the team understands the architecture, they are aligned in their vision and objectives. This alignment is what allows teams to move along the same path, regardless of their unique roles and responsibilities. Essentially, we are talking about creating a unified perspective that helps all the stakeholders, including developers, project managers, QA, and even clients, maintaining a consistent view of the architecture. This alignment results in more streamlined decision making, lowering the chances of costly missteps caused by miscommunication or misunderstandings. Alongside facilitating alignment, software documentation promotes the profound concept of asynchronous growth. Imagine your company decides to scale, attracting new hiring or exploring new verticals. When new members join the team, how would you bring them up to speed with the software architecture? This is where documentation comes in. Instead of relying on individual knowledge transfer, which can be inconsistent and time-consuming, well-documented software architecture can provide an onboarding mechanism that is available 24/7. Furthermore, Documentation is not just an invaluable resource for the present, but also an investment for the future. As the software evolves, the documentation stands as chronicle of the project's journey, helping future teams understand why certain architectural decisions were taken. In summary, if you want to streamline your internal processes, scale effectively, and create a robust foundation for both the present and future growth of your organization, you absolutely need to prioritize software architecture documentation. Before we start, I want to spend a few words on another initiative that I started a few years ago. It's a newsletter. It's called Dear Architects. It's a free newsletter where I collect weekly the articles I found most interesting and that can spark new ideas for you and your teams. Every newsletter comes with 5 distinct resources on software architecture. The content is a collection of great resources found on the web that lands in your inbox every week. I cover topics like generative AI, distributed system, design patterns, observability, migration and modernization journeys, case studies shared by well-known brands in the industry, and way more. If you are interested to know more, click the link in the description and register now. No advertising, completely free. Join the community composed by tens of thousands of members already. We'll now dive into the details of various documentation techniques. Let's start with the ADR, or Architecture Decision Record. It's an effective approach to documenting architectural decisions made during the software development process. It was first proposed by Michael Nygaard to maintain an organized timeline of decisions, providing context around the problems addressed, the solution adopted, and the reasons behind those choices. An invaluable aspect of ADRs lies in how they facilitate informed decision making in the future. By summarizing choices in an accessible format, ADRs serve as a guidepost around past decisions. This understanding minimizes duplication and fosters consistency, as developers can refer back to these decisions when facing similar conundrums. Very often I have experienced new joiners that were asking why a certain decision was made, and thanks to ADR I was able to immediately provide context and clear understandings and insights why certain things were happening. ADR also improve project continuity as they offer a detailed understanding of why specific decisions were made. This is crucial, especially in large projects or organizations where team members might change over time or are spread across the world. Having articulated reasoning and clear documentation ensures smoother transitions and continual progress, even with new team members on board. ADRs are comprehensive. Beyond just recording the outcome of a decision, ADRs detail the context in which a decision was made, and context in architecture is everything. It also collects alternatives considered during the process and potential consequences anticipated. This holistic view helps developers to understand not just the what, but also the why, how, and when of decisions, fostering a more profound understanding of the project's development path. By openly documenting and sharing decision records, it ensures that all stakeholders are on the same page. This transparency bolsters trust, facilitates collaboration, and leads to more cohesive development efforts. In conclusion, ADRs serve as a powerful tool for improving project management and decision making in software development. I use ADRs many times in my project, even with customers. I also ask multiple teams to write down important decisions on ADR. Bear in mind that you don't have to create an ADR for every single decision you make, but the important one that impacts the direction of travel of a tech department is a mandatory for me. For example, imagine you are embarking a modernization journey and you have to define at the beginning the guardrails for the whole organization. Things like version control strategy, observability, communication between microservices, security, a specific pattern that you want to integrate with the third-party system, and so on. These are great candidates for an architecture decision record. There are several templates available to define an ADR. I provide a link in the description below. So bear in mind there isn't just a single approach. Find the one that fits you better. Next up is the request for comments, or RFC, a comprehensive and effective communication process used to capture feedback, suggestions, or standardization around a particular technology system or protocol. The RFC process serves to improve the understanding and applicability of a concept through a widely accessible mechanism. It enables experts, developers, and every other stakeholder for a project to contribute with their insights. This in turn enhances the overall quality of a particular proposal or standard. This collaborative approach allows for crucial refinements and optimization which would have been challenging to achieve solely by the initial author. Additionally, RFCs help to promote discussion and consensus building within the community, fostering a shared understanding around the subject matter. The open nature of the RFC process not only encourages fresh perspective and innovative ideas, but also provides valuable feedback for the author. By embracing constructive criticism, potential issues, and alternative ideas, RFCs can evolve into a more robust and comprehensive standards and protocols. In fact, in many open source projects, you can propose new features via RFCs. Moreover, as RFCs progress through discussion, reviews, and revision, they serve as a reliable source of documentation and learning. They document the rationale behind proposed solution, keeping an historical record of the development process and the decision made along the way. This information can be particularly useful for new team members or other professionals looking to gain insight in specific technologies or standards. A great advantage of RFC is that they enables an asynchronous communication where everyone can join the conversation. Everyone is different. There are introverts, extroverts. There is maybe a wrong day for a person, and not everyone performs great during a meeting. RFCs, as an asynchronous mechanism to collect ideas and feedback, bypass all these challenges because usually it's time boxed and allows everyone to express their thoughts. I've seen teams using RFC even to discuss API evolution, so all the consumers of an API can share their requirements and propose new ideas. Most of the time, RFCs are stored in the version of control system, GitHub, GitLab, and similar. So everyone in tech department has access and can contribute. In summary, the request for comments process enriches the understanding of technology systems and protocols by engaging a wide array of experts' feedback and fostering a collaborative approach to problem solving. As these perspectives merge and evolve, RFC became a powerful repository of knowledge. Also in this case, I left a link to an RFC template in the description below. Now let's move to another technique called event storming. It's a powerful workshop technique developed by Alberto Brandolini, aims to enhance the understanding, design, and modeling of business domains. By focusing on domain events, which represent significant changes in the domain, event storming serves as a visual and collaborative exploration that invites various stakeholders to work together in creating a common understanding of the business process. I've joined several event storming sessions in the past, and I can tell you that it is invaluable what you can get out of that. One of the core strengths of event storming is that it fosters a unified understanding by bringing together every participant, from business experts to developers. Event storming goes further by promoting a naturally collaborative dynamic where every participant's viewpoint is acknowledged and incorporated. In essence, the process creates an environment where the intersection of ideas between different minds, technical and non-technical, crafts a shared understanding of realities. This is the perfect way to align the business requirements with the technical implementation. Very often, I have seen people that forget that what we are coding is not just code, is generating value for your customers, for the people that are using your software. This is a fundamental catch. What goes in production is the understanding or misunderstanding of developers, as well said by Brandolini. Having product people in the same room of developers removes the barriers of just thinking to the technical side, and we can start to focus more on the business outcomes and focusing on your customers. That's the key learning of this approach. This methodology works perfectly with domain-driven design or DDD, as specifying key domain events can lead identifying DDD constructs such as aggregates or bounded contexts. These insights become pivotal when designing and implementing efficient software. It starts with a broad exploration, often called the big picture, followed by more detailed exploration supporting a flexible and agile adoption of the insight extracted from the process. Finally, event storming is a potent learning tool and a fast, user-friendly way to model a domain. Be it a new project or an existing architecture requiring improvements, event storming enables better clarity with effectiveness. Very often, during an event storming session, developers had the opportunity to tweak a feature and make it easier to implement, reducing the friction with the product team and creating a synergy within the extended team instead of creating silos between departments. I used event storming for onboarding new developers in a team, for clarifying how to evolve a specific domain, and even to model complex features that touch multiple domains, if not the entire system. Often people think it might be a waste of time. After trying 1 or 2 days of event storming session, I got customers telling me that these techniques did in 2 days what they were used to do in 5 months. Don't underestimate this approach because it's a must-have in particular parts of the software for making sure that what is built is what the business expects and is delivered with clear objectives in mind and possibly on time. In the video description, I've added also a link about event storming if you want to deep dive into the topic. Last but not least, the C4 model, created by software architect Simon Brown, is a powerful approach to visualizing and documenting a system's architecture. It stands for context, container, component, and code, and presents a multi-layered view of software architecture, making it more accessible of different stakeholders depending on their requirements. The simplicity of the C4 model makes it easy to understand and apply, bringing a wealth of benefit to the software development process. One key advantage of the C4 model is its layer structure, allowing for a diverse understanding according to stakeholders' needs. For instance, non-technical stakeholders might find the context layer enough for understanding what they are looking for. Furthermore, this model encourages to use of common language and notation, reducing misinterpretation and fostering a shared understanding among team members. It enables effective knowledge transfer across the team, making it easier for new members to understand the software architecture from different points of view. By visualizing complex systems, the C4 model supports architectural design decisions. It highlights potential issues, dependencies, or areas of improvements that might not have been as apparent in the code alone, leading to well-informed decisions. In conclusion, the C4 model simplifies understanding of complex software systems by breaking them down into more manageable, communicable components. In my experience, I've seen just one challenge with this model. The fourth C, code, refers to the code diagram that tends to get out of date very quickly. So watch out and make sure your diagrams are up to date. Obviously, this one is one of the many approaches, but I believe it's one of the most pragmatic. As you have seen, I didn't provide you with just one technique, but several of them. You will discover how much impact good documentation has during the software development lifecycle, and when it happens, I encourage you to write down your experience in the comments below. Investing time in software modeling is not a waste of time. Thanks to that, you are going to have a comprehensive understanding of what you need to codify or translate into code, and you will be able to reach your goal faster. So, happy documenting, and see you in the next episode of My 50 Cents.